all you know that we are continuing binomial theorem. Last day we did some problem based on calculus and summation sigma. Let us take one example from that concept to uh, to remind you what was taught last day in short span. Let's see
Okay, sir.
that sum related to sigma we did last day and few problems based on calculus. Today we will learn greatest term in an expansion. See, the sum is alpha is equal to into NCR, that is alpha, and beta is summation of R0 to N NCR by R plus 1 by 1 by N plus 1, where this is alpha and beta. देखने में बहुत टफ लग रहा है, बट जब स्टार्ट होगा सम देखो कि ये इतना टफ नहीं है जो हम समझता है. हाँ, ठीक है, लुक वेरी टफ, बट once you start to simplify, the toughness will be diluted.
Okay, sir.
Now the question is, if less than 281, then integer type question, value of n. How it is related to competitive level? It came in JEE Main 2024, JEE 2024 April 8th, second session. So our first role is simplifying the this sigma. We will remove the sigma and see how to remove. See, alpha is equal to given what? Sigma of 0 to n 4 r square plus 2r plus 1 NCR. Sigma means summation, so you can split the bracket with this plus sign. ये जो प्लस साइन है उसके साथ हमको ओपन करना है ये ब्रैकेट को. देखो, फोर आर स्क्वायर into NCR plus sigma टू r into NCR plus sigma 0 to n NCR. नाउ इसका जो वैल्यू है ये तो हमको पता है. वाई? लास्ट डे वी आर टॉट. देखो जस्ट इन शॉर्ट स्पैन लेट अस रिमाइंड. 1 प्लस एक्स होल टू द पावर n, ये था c0 प्लस c1x प्लस c2x स्क्वायर up to cn x to the power n. So this is the expansion of 1 plus x whole to the power n. ये x plus 1 में x के जगह में 1 पुट कर दिया तो क्या होगा? 1 plus 1 क्या होगा? 2 c0 plus c1 plus c2 up to cn. So ये क्या हुआ? NCR. देखो R0 to n है कि नहीं?
यस सर.
तुम पूछोगे कि यहाँ पे n कहाँ है? ये n साइलेंट है. तो यह है सम NCR समेशन R0 to n. इसका रिजल्ट है 2 to the power n. So we will drag the value, we will plug the value, and instead of this we can put 2 to the power n. So in the simplification portion, one part simplified value is placed. Now other parts to be simplified. Here you see 4 has no role and here 2 has no role. So just kick out them. Out of the summation sign you put. उसको summation sign का बाहर put करो. See, 4 will be brought out. R square NCR. 2 will be brought out. Summation R0 NCR. ठीक है?
ओके सर.
नाउ NCR का जो फॉर्मूला, बेसिक फॉर्मूला, उसको इस्तेमाल करना पड़ेगा. क्या है NCR का बेसिक फॉर्मूला? 4 summation R0 to n, these R square will remain, but this NCR factorial n minus r into factorial r plus 2 r instead of this NCR factorial n plus 2 to the power n. तो इतना तक तो समझ में आ ही गया. जस्ट फॉर्मूला का यूज हुआ. ठीक है? यहाँ पे देखो फॉर्मूला का जस्ट यूज किया. हाँ,
यस सर.
नाउ मोर सिंप्लीफिकेशन का जरूरत है. कैसे? देखो 4 1 r factorial r means what? Factorial r means r into factorial r minus 1. So ये r square तो रह गया. Factorial n minus r, instead of this r into r minus 1 factorial. So same thing to be done here. In that case, we'll get one privilege, that r can be cancelled. 2 summation r is equal to 0 already r is there, but in this bracket I can write factorial n r into see 1 r will get cancelled, but still 1 r stays here. एक r कैंसिल हो गया, एक r रह गया. ठीक है.
Yes.
यहां पे भी देखो, यहां पे भी यहां पे r कैंसिल ही हो गया, एक प्रिविलेज मिला. नाउ ये जो r बचा हुआ है इसको ऐसे इस करना पड़ेगा, r into n. ये r के जगह में यहाँ पे r-1 फैक्टोरियल है, यहाँ पे r है, सो इसको r-1 प्लस 1 हम लिख सकता है. Other part will remain unchanged. In this case, now our role is to factorize this factorial n. How? Instead of factorial n, I can write n minus 1 factorial. And instead of this, I can write n minus 1. But you can say how? n minus r था, n minus 1 कैसे बन गया? नहीं बना. देखो n minus 1 एक ब्रैकेट में है, हम r लिखा, तब तो n minus 1 माइनस r, ये 1 कहां से आ गया? बैलेंस करने के लिए हम ये लिख दिया. ये फैक्टोरियल टू टू द पावर n. समझ गया?
Yes, sir.
ना ये यहां पे जो ब्रैकेट है इसको हम रिमूव करूंगा विद दिस प्लस साइन. और समेशन सी r-1 into factorial n, r-1 into factorial n by plus 1 into factorial n, 1 into factorial n. हम दोनों पार्ट में ये जो है 4 into this thing, that is broken into the two part. एक r-1 into factorial n by denominator, 1 into factorial n by denominator. और in this part what can I do? I can take, यहाँ पे देखो r 0 से n तक जा रहा है, तो वेरिएबल वेरी कर रहा है क्या? r. n तो फिक्स है, तो एक
Yes.
जो फिक्स है, कांस्टेंट है, उसको हम बाहर फेंक दिया, और ये जो वैल्यू मिला ये तो 2 to the power n ही रह गया. तो यहाँ पे जो वैल्यू मिला, यहाँ पे देखो n एक तो कम हो गया, तब ये यहाँ पे लिखना पड़ेगा r 1 to n, बिकॉज अगर r 0 हो जाए तो नेगेटिव हो जाएगा फैक्टोरियल में, वो तो अनडिफाइंड, तो 1 to n हो गया। तो इंस्टेड ऑफ दिस n minus 1, व्हाट कैन आई राइट? सी, इसका जो कैलकुलेशन है, और देखो ये सेम कैलकुलेशन यहाँ पे भी आ रहा है, इसका कैलकुलेशन हम अलग से करूंगा। ठीक है,
ओके सर।
कैसे करूंगा देखो, तब समझ में आएगा। ये जो हमको मिला n minus 1 फैक्टोरियल, n minus 1 r minus 1 r minus 1 factorial r1 to n. Few minutes back we got what? 1 plus x whole to the power n. Now n minus 1. Instead of n I can put n minus 1. तब ये क्या होगा? n minus 1 c0, n minus 1 c1x plus n minus 1 c2x square. Okay, it will proceed like that. X to the power n minus 1. Yes or no?
Yes sir.
So if I put x is equal to 1 now that will give you 2 to the power n minus 1. Okay, 2 to the power n minus 1, and this is c0 plus c1 up to c2 cn. So this value actually is the value of this. If you open it, you will get, it will be what, like this. See, instead of this, what can you write? N minus 1 C R minus 1. Yes or no?
Yes sir.
So if you put R is equal to 1, see, instead of this, you can write 2n summation R is equal to 1 n minus 1 C R minus 1. ये 2 to the power n जैसे था ऐसे ही रहेगा. So if you get NCR, sum of n 0 to n, that is 2 to the power n. So if you get this summation, then n will be reduced by 1. है कि नहीं?
Yes sir.
देखो यहाँ पे NCR, NC0 plus NC1 plus MC2, sum of the coefficient is to the power n. यहाँ पे n अगर 1 पुट करो, n minus 1 C0, n minus 1 C1, okay, yeah, up to n minus 1 Cn minus 1. So that is 2 to the power n minus 1. तो इसका समेशन 2 to the power n minus 1 होगा. Okay.
Okay sir.
Now the same thing will be done here. Here 4, you see, you observe carefully. Now this r minus 1 factorial, r minus 1 will get cancelled. 1 r minus 1 will get cancelled and it will become r minus 2 factorial. So this thing will be reduced to r now 2 to n factorial n. Why 2 to n? Few terms are already cancelled. Understand? 2 terms are cancelled.
Okay sir.
Those terms are cancelled to be calculated. Here r minus 2. Now 4 into this plus 4 into this thing. See, this thing and that thing same. So directly I can write, instead of this, directly I can write that result. Understand?
Yes, sir. Understood.
That factorial n, and if you have doubt, okay, I am rewriting that. Factorial n means, you know, till now there is 1 to factor n. Now factorial n means n into factorial n minus 1, n, 1 n will come out. It has become n minus 1 factorial. Instead of this thing, you can write n minus 1 r minus 1 factorial into r minus 1 factorial. इसका वैल्यू तो अभी निकल गया. देखो ये जो रिजल्ट वो तो सेम ही रहेगा. इसका वैल्यू तो 2n, इसका वैल्यू क्या है जो अभी मिला हमको 2 to the power n minus 1 प्लस इसका जो वैल्यू मिलेगा 4n अगेन n minus 1 cr minus 1 and what about this 4 see here r minus 2 we have got, so you write this thing, this factorial n as n minus 1 n minus 2 factorial n minus 1 n minus 2 factorial. Why? Because r minus 2 factorial we got. So keeping the parity with that r, I have to reduce n to n minus 2. Okay?
Okay, sir.
See, summation sign still persists. Instead of n minus r, you can write n minus 2. Instead of n, I can write n minus 2 to balance r minus 2. Here r minus 2 factorial plus this n minus 1 कहाँ जाएगा? बाहर चला जाएगा. Under summation, what will remain? N minus 2 factorial by n minus 2 r minus 2 factorial r minus 2. Instead of this, what can I write? Plus 4n n minus 1 c1. Here already we got, sorry, here I can write 2 to the power n minus 1. Here 2n 2 to the power n minus 1 plus 2 to the power n. See, this will remain unchanged. 4n n minus 1 summation. This can be written as n minus 2 cr minus 2. Yes or no? This is factorial. This is now n. N c factorial n by n minus r factorial into factorial r. That 4n and 2n will be added and produce 6n 2 to the power n minus 1 and these 2 to the power n. Now you observe that once we get summation of ncr 2 to the power n, n minus 1 cr minus 1 2 to the power n minus 1. So n minus 2 cr minus 2 in the same manner 2 to the power n minus 2. Okay?
Okay, sir.
So here you see 4n n minus 1 instead of this I can write 2 to the power n minus 2. 6n, laws of indices in junior class you are taught. Laws of indices, 2 to the power n by 2 plus 2 to the power n. Here 4n, n minus 1, so we are in the verge of simplification of the first part. What is common to each of this algebraic expression? 2 to the power n. I can take 2 to the power n common and see the outcome. 4n, n minus 1 by 4 plus, see, I missed out that 2 by 2, 2 and 6n will get cancelled, 3n in 3n plus, see, I have taken 2 to the power n common and against it 1 will remain. 4 cancel. You see the outcome, n square minus n plus 3n plus 1, 2 to the power n square to n plus 1. So it is really gobsmacking that huge calculation is reduced to its simplest part. Yes or no?
Yes, sir.
See that huge expression, which, see, you know, it encroaches time also. That huge expression is reduced to simple what? 2 to the power n plus 1 whole square. So we have got alpha is equal to 2 to the power n plus 1 whole square. That result we have got. Beta is not that much of tough because you know the expressions in will be integrated, binomial expression in this case. See, we know 1 plus x whole to the power n is C0 plus C1x, C2x square up to Cn x to the power n. Now, if I integrate it both sides with respect to x, see, it will give you C0 C1 x square by 2 plus C2 x cube by 3 up to Cn x to the power n plus 1 by n plus 1 plus k. Now, what about that part? See, here directly we can integrate using x to the power n plus 1's formula. C0 C1 x square by 2 C2 x cube by 3 up to Cn x to the power n plus 1 by n plus 1 plus k. That is integration constant. We have to find that. How to find? See, if I can remove the whole thing. See, I forgot to integrate this part C0, its integration is x, C0x. I did not put the integration sign in right hand side. Directly I have got C0x. Now I am putting x is equal to 0. X is equal to 0 if I put, I will get 1 by n plus 1 is equal to k. Once you get 1 by n plus 1 k, you put that. Therefore, this equation will be turned into 1 plus x to the power bring k in left hand side, it is C0x C1 x square by 2, C2 x cube by 3 up to Cn x to the power n plus 1 by n plus 1. What is k? K is just derived 1 by 1 plus 1. So k, we have got 1 plus x to the power n plus 1 by n plus 1 minus this. Could you follow this? That is k. Yes or no?
Yes, sir.
Now, I will put x is equal to 0, 1 now. If I put so, what I will get? 2 to the power n plus 1 minus 1 by n plus 1. C0, C1 by 2, C2 by 3 up to Cn by n plus 1. Okay. Now, instead of writing all this plus sign, I can write summation of CR NCR by n plus 1, where R starts from, sorry, NCR by R plus 1, R starts from 0 to n. क्यों? ये क्यों? R का वैल्यू 0 पुट करो, क्या आएगा देखो, NC0 by 0 plus 1, ये फर्स्ट टर्म आ गया. Now increase by 1, R का वैल्यू 1 पुट करो, NC1 means C1, 1 plus 1 2.
Okay, sir.
ठीक है. तो
Yes.
ये जो रिजल्ट जो मिला, so that is the sum of the coefficient with the with some constant term in the denominator. So I can express it with that summation sign. Now come to the expression beta given in the question. Beta is given what? Beta is given summation of NCR by R plus 1, where R 0 to n plus 1 plus n. So we have got a allure, we have got a path. इसका जो वैल्यू है अभी हमको हाथ में आ गया है कि नहीं?
Yes, sir.
So just plug this value and put here 2 to the power n plus 1 minus 1 2 to the power n plus 1 by n plus 1 cancel it. See, beta also derived with a simplified version. Yes or no?
Yes, sir.
So alpha and beta both we have got. Now let's see what is given. Alpha we got what? Let us find alpha is 2 to the power n plus 1 whole square. And here one condition is given. What condition? That 140 less than 2 alpha by beta less than 281. Now these derived alpha and beta help us how? Let's see. This 140 will not be changed. 2 instead of alpha, what value we got? Instead of alpha, 2 to the power n plus 1 whole square. 2 to the power n plus 1 whole square. Instead of beta, few minutes back we have got, that is beta, 2 to the power n plus 1 by n plus 1 whole square, or n plus 1 less than 281. Okay? Yes or no?
Yes, sir.
Now we are one step behind the calculation. Final calculation. Anything will be cancelled? Just 1 minute. Huh? Please hold on.
Okay, sir. No worries.
Okay. Sorry. Huh? Sorry for the delay.
Okay, sir. No worries.
See this part. Oh. See here. That n plus 1 will go up. Cancel. So at last we have come to a conclusion that 1 plus n plus 1 whole cube lies between 281 and 140. Now, what will be the value of n? See, let us go through the question. What is n? Any criteria of n is given told here? Let's see. What is n? That is the question. No, n is just power of power of a binomial expansion. So it must be integer. So integer natural number. So up to reaching this stage, if I take n 0, n is equal to 0, is that condition be satisfied? No. Why? If I put 0, 0 plus 1, 1 cannot lie between that interval. Yes or no?
Yes, sir.
So I can't take 0. If n1, see 1 plus 1, 2, 2 cube 8, it cannot lie between this. If n1, it will be 8, it cannot lie between 281 and 140. Now, if I put 2, see 27, it cannot lie between 281 and 140. If I put 3, see 64, cannot lie between 281 and 140. But if I take 4, then also it will be 125. It cannot lie between 281 and 140. If I put 5, if n is equal to 5, देखो 5 plus 1 6, 216, it must lie between this and this. So what will be the value of n? Therefore n is equal to 5 for which above inequality satisfied. Yes or no?
Yes, sir.
So this is the result of this expansion. Now we'll skip that. This sound a little bit tough and obviously time consuming in exam. In exam, if you get this sum, if you are if you can't keep your patience, it is difficult. ঠিক আছে?
Okay, sir.